Now in this lecture we find out the radius of a circle. In the drawing we have a circle. We know that inside this circle we have chord dB. The size of this chord dB is 2. Chord dB equals to 2 units length. We also have chord AC. Chord is AC equals to the square root of 2 units length. And we have also, this is angle DEB. The size of this angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So in the first step, we join points A and D together by a straight line. By joining points D and A, we get that here, this is peripheral angle BAD. Again, peripheral angle BAD, this is peripheral angle BAD, and this peripheral angle BAD is subtended on chord BD. Again, this is peripheral angle BAD that is subtended on this chord called BD. We define the size of this peripheral angle BAD is x over 2. Again, peripheral angle BAD is subtended on chord BD. We define the center of this circle. This point is point O. In the next step, we join points O and D together by a straight line. Likewise, we join points O and B together by a straight line. By doing this construction, we can do straight angle DOB. This is straight angle. This is straight angle DOB, and this straight angle DOB is subtended on chord BD, exactly like this peripheral angle BAD. It is also subtended on the same chord called BD. Okay, now we can implement rule 13 in our drawing. I'll repeat quickly on rule 13. According to rule 13, a certain angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB. This is peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. Again, peripheral angle ACB subtended on this chord called AB. Likewise, we have here center angle AOB. This is center angle AOB that is subtended on the same chord called AB. And according to this rule, rule 13, the size of peripheral angle AOB is twice as large of the size of this peripheral angle ACB. One, because both of them are subtended on the same chord. When you have two angles, peripheral angle and the center angle, that they both subtended on the same chord, then the size of the center angle must be twice as large as the size of the peripheral angle that is subtended on the same chord. So this is the center angle ACB that is subtended on chord AB. This is the center angle AOB that is subtended on the same chord called AB, and therefore the size of center angle AOB must be twice as large as the size of this peripheral angle ACB. And the size of this peripheral angle ACB is theta, and therefore the size of the center angle AOB that is subtended on the same chord called AB must be equal to 2 theta. So we can implement rule 13 in our drawing. Why? Because in our drawing we have, this is peripheral angle BAD. The size of this peripheral angle BAD is x over 2, and this peripheral angle BAD is subtended on chord DB. Likewise, we have the certain angle BOD. This is the certain angle BOD that is subtended on the same chord called DB. And therefore, according to rule 13, the size of this peripheral angle must be twice as large as the size of this peripheral angle BAD. And the size of this peripheral angle BAD is x over 2. Therefore, the size of this certain angle BOD that is subtended on the same chord called BD must be equal to x. According to rule 13, of course. Okay. So here we have, this is peripheral angle CDA, and this peripheral angle CDA is subtended on chord CA. We will define the size of this peripheral angle CDA. The size of this angle CDA is y over 2. In the next step, we'll join points O and C together by a straight line. And we'll join points O and A together by a straight line. When doing this construction, we can do the certain angle COA. This is the certain angle COA, and this certain angle COA is subtended on chord AC, exactly like this peripheral angle CDA that is subtended on the same chord called AC. Therefore, according to rule 13, the size of certain angle COA must be twice as large as the size of this peripheral angle CDA that is subtended on the same chord called AC. And the size of this peripheral angle is y over 2. Therefore, the size of this certain angle that is subtended on the same chord called CA must be equal to y. Okay, so in the next step, we'll present to you the law of cosines, and we'll implement the law of cosines in this triangle BOD. So I'll repeat quickly on the law of cosines. Actually, the law of cosines is true in any triangle. So this is triangle ABC, that could be any triangle. The length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. This is angle theta, so angle BAD, the size of this angle BAD is theta. So according to the law of cosines, in this triangle ABC, this could be any triangle, the following equation will be true, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So in the next step, we'll copy this triangle DOB in a new page, and we'll implement the law of cosines in this triangle DOB. What is the length of line segment OB? Line segment OB starts from point O, that is the center of the circle, and then at point B, it is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OB is the radius of the circle. We define the radius of the circle as R. So OB equals to R. R is the radius that we are looking for in this question. Likewise, OC is also R. OA is also the radius of this circle that is R. And finally, OD is also the radius of this circle is equals to R. R units in its name. So DO equals to R. OB also equals to R. And this is line segment or side DB equals to 2 units in its name. So actually, this is triangle OBD with the coordinates from the original domain. In the next step, we'll implement the law of cosines in this triangle, triangle OBD. So according to the law of cosines, in the triangle OBD, cosine x equals to OD squared. OD is R, therefore OD squared is R squared, plus OB squared. OB is also R, therefore OB squared is R squared, so it is R squared, minus DB squared. DB is 2, therefore DB squared is 2 squared, it is 4, so it is minus 4. Divided by 2 times A. So it is 2 times A, and A is OD. OD is R, so it is 2 times R times B. B is OB, therefore we substitute OB by B, we substitute OB by R. Again, OB is R, therefore we substitute OB by R. So we found out that cosine x equals to R squared plus R squared, that is 2R squared, minus 4, divided by 2 times R, that is 2R squared. So 2R squared over 2R squared is 1, and we have minus 4 over 2R squared. So it is equals to 1, and we have here minus 4 over 2R squared. Here we divide both the numerator and the denominator of this expression by 2, and we get that minus 4 over 2 is minus 2, and 2R squared over 2 is R squared. So for real, this is equation 1. According to equation 1, we actually found out that cosine x equals to 1 minus 2 over R squared. In the next step, we'll copy triangle AOC in the new page, and we'll implement the law of cosines in this triangle, triangle AOC. side AC equals to the square root of 2 units in its length, AO equals to R, and CO also equals to R. And this is angle AOC, this is Y. So actually, this is triangle AOC, this is a copy from the original drawing. Now we'll implement the law of cosines in this triangle, triangle AOC. According to the law of cosines, we get that cosine y, equation 2, cosine y equals to AO squared. AO is R, therefore AO squared is R squared, plus CO squared. CO is also R, therefore CO squared is R squared, so it is plus R squared minus AC squared. AC is square root of 2, therefore AC squared is square root of 2 squared, that is 2. So in total, in the numerator we have R squared plus R squared minus 2 over 2 times AC. AC is R times OC. Again, over 2 times AO. AO is also substitute AO by R times OC. OC is also R, so we substitute OC by R. So if we should find out that cosine Y equals to R squared plus R squared is 2R squared minus 2 over 2 times R times R. 2 times R times R is 2R squared. So in equation we should find out that according to equation 2, cosine Y equals to 2R squared over 2R squared is 1, and we also have minus 2 over 2R squared. So cosine Y equals to 1, and here we have minus 2 over 2R squared. Here we divide both the numerator and the denominator of this expression by 2, and get that minus 2 over 2 is minus 1, and 2R squared over 2 is R squared. So from here I should find out that according to equation 2, cosine Y equals to 1 minus 1 over R squared. Then again, according to equation 2, I should find out that cosine Y equals to 1 minus 1 over R squared. In the next step, I'll copy triangle AED in a new page, and we'll implement rule 4 on this triangle, triangle AED. So actually, this is triangle ADE. This is a curve from the original drawing. This triangle ADE, we have this is angle AED. This is equals to x over 2 degrees in its size, and this is angle EDA. That is equals to y over 2 degrees in its size. And we have also this angle AED. Actually, those three angles, 1, 2, 3, all those three angles, they are all defined as an axial angles of this triangle AED. Why? Because they are located inside triangle AED. So all those three angles are defined as an interior angles of triangle AED. All those three angles. While this is angle BED, the size of angle BED is 45 degrees, and this is angle BED that is located outside triangle DEA, and this angle BED is defined as an axial angle in relation to this triangle EDA because it is located outside triangle EDA. And therefore, this angle is defined as an axial angle of triangle EDA. So this is an axial angle of triangle EDA. So I conclude actually found out that those three angles that are inside triangle EDA, they are all defined as interior angles of this triangle EDA, while this is angle BED that is located outside triangle EDA, and therefore this is defined as an axial angle of this triangle EDA. So now we can implement rule 4 in our drawing. So I will present to you rule 4, and we implement the new rule 4 in our drawing, this drawing. So we'll click quickly on rule 4. According to rule 4, the axial angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have those three angles A, B and C. Those three angles are defined as an axial angles of this triangle, while this is angle E that is located outside this triangle, and therefore this angle E is defined as an axial angle in relation to this triangle. And according to this rule 4, the size of the axial angle E is equal to the sum of the two interior angles that are not adjacent to it. This is angle C that is definitely adjacent to angle E. Again, angle C is adjacent to angle E. The two other interior angles that are not adjacent to angle E are those two angles, A and B. And according to this rule 4, the size of the axial angle E is equal to the sum of the two interior angles that are not adjacent to it. That is to say, angle E equals to A plus B. Again, angle E equals to A plus B. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have this is the interior angle BED. The size of the interior angle BED is 45 degrees, and according to rule 4, the size of this interior angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle DEA that is definitely adjacent to this angle BED. The two other angles that are not adjacent to it are x over 2 and y over 2. And the sum of those two interior angles that are not adjacent to it is x over 2 plus y over 2. And therefore, according to rule 4, the size of this interior angle BED is equal to x over 2 plus y over 2. Again, the size of angle BED is x over 2 plus y over 2. So I write it down. First we found out that according to rule 4, the size of the internal angle BED is equals to x over 2 plus y over 2. But it is given as a question that the size of angle BED is 45. So consider angle BED by 45, and we get that 45 is equals to x over 2 plus y over 2. So here we multiply the equation by 2, and finally we get that 45 degrees times 2 is 90 degrees. So 90 degrees equals to x over 2 times 2 is x, plus y over 2 times 2 is y. So we should found out that x plus y equals to 90 degrees. Here we subtract x from this equation, and finally get that angle y equals to 90 degrees minus x. So according to equation 1, y equals to 90 degrees minus x. And here we should found out that cosine y equals to 1 over r squared. So I copy this equation 2 again in a new page. According to equation 2, cosine y equals to 1 minus 1 over r squared. And just right now found out that y equals to 90 degrees minus x. Therefore, we can substitute y in this equation 2 by 90 degrees minus x. We'll do it now, and we get that according to equation 2, we have cosine y, so it is cosine, and y is 90 degrees minus x, and it is equals to 1 minus 1 over r squared. So for equation we found out that according to equation 2, cosine 90 degrees minus x equals to 1 minus 1 over r squared. We have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So according to this trigonometric identity, we can substitute cosine 90 degrees minus x in this equation, equation 2, by sinus. We can substitute cosine 90 degrees minus x in this equation, equation 2, by sinus x. We do it now, and we get that according to equation 2, cosine 90 degrees minus x is sinus x, so sinus x equals to 1 minus 1 over r squared. This is according to equation 2, while according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So we have here the expressions for sinus x and cosine x in terms of r. And we also have the trigonometric identity that states that sinus square x plus cosine square x equals to 1. Okay. In the next step, we substitute sinus x in this equation, in this trigonometric identity, by 1 minus 1 over r squared, because it is equal to sin x, and substitute cosine x in this equation, in this trigonometric identity, by 1 minus 2 over r squared, because 1 minus 2 over r squared is equals to cosine x. We do it now, and this way we get equation 3. So according to equation 3, we have sinus square x. Sinus x equals to 1 minus 1 over r squared, and therefore sinus square x will be equal to 1 minus 1 over r squared plus cosine square x. We have cosine x equals to 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared, and it is equal to 1. So here we will define t equals to 1 over r squared. Now we can substitute 1 over r squared in this equation 3 by t. We do it now, and we get that according to equation 3, we have 1 minus 1 over r squared. 1 over r squared is t, so substitute 1 over r squared by t. So in total this expression will be equal to 1 minus t squared. We have also plus 1 minus 2 over r squared. Here we multiply this expression by 1. We can multiply anything by 1, because by multiplying something by 1 will not change the value of the expression. So this expression equals to 1 minus 2 times 1 over r squared, and 1 over r squared is t, therefore we substitute 1 over r squared this expression by t. So in total this expression will be equal to 1 minus 2t squared, and this is equal to 1. So in total we shall find out that according to equation 3, one minus t squared plus 1 minus 2t squared equals to 1. We'll open the brackets on this side of equation, equation 3, and get that according to this equation 3, we have here 1 minus t squared. 1 minus t squared equals to 1 squared, it is 1, plus t squared minus 2t, and we have also plus 1 minus t squared. 1 minus t squared equals to 1 squared, it is 1, plus 2t squared. 2t squared is 4t squared, minus 2 times 1 times 2t. So minus 2 times 1 is 2, and 2 times minus 2 times 2t is minus 4t. This is minus 4t, this equals to 1. So here we have 1 on both sides of the equation, so 1 gets cancelled. They cancelled 1. On this side of the equation we will have only with t squared plus 4t squared is 5t squared. And we have also minus 2t minus 4t is minus 6t. And we have 1 minus t squared plus 1 minus 2t squared is 2t. And we have also minus 2t minus 4t minus 6t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have also minus 2t minus 4t minus 6t is minus 4t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have 1 minus 2t minus 4t minus 6t is minus 4t. And we have 1 so here plus 1 equals to 0. So if we found out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now a specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t, so x equals to t. The coefficient a equals to 5. The coefficient b equals to minus 6. And finally, the coefficient c equals to 1. The only thing that is left to do is to put the data for our specific quadratic equation, this data inside this general formula for x, and in this way we find out the value of the values of t, because x equals to t. So we do it now, and we get that again x equals to t, so substitute x by t, so 3 equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B equals to minus 6, therefore b squared is minus 6 squared, that is 36. Minus 4 times a. A is 5, so minus 4 times 5 is minus 20 times c. C is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, therefore 2a is 2 times 5, that is 10. So conclusion, we found out that t equals to 6 plus minus, t equals to 6 plus minus, and 36 minus 20 is 16. So the square root of 16 divided by 10. Okay. Now we know that the square root of 16 is 4. So in conclusion, we found out that t equals to 6 plus minus, again the square root of 16 is 4, so it is 4 divided by 10. So here we actually found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So if we found out that t equals to 1, from one side, but from the other side, according to our definition, t equals to 1 over r squared. So we can substitute t in this equation by 1 over r squared. We do it now, we get that 1 over r squared equals to 1. Here we multiply this equation by r squared, and we get that 1 equals to r squared. So here we take a root out of this equation, and finally we get that r, this is the value that we are looking for, is equals to the square root of 1, that is 1. So according to this, to the first solution for t, the radius of this circle, the radius r equals to 1. But it is actually impossible that the radius of this circle r is equals to 1. Why? Because of the fact that we know that this is called dB is equals to 2, and code dB is definitely not the diameter of the circle. Again, code dB is definitely not the diameter of the circle. Okay, and we note that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. The diameter of this circle is 2r. So the diameter of 2r of this circle is definitely greater than dB, that is not the diameter of the circle. So the diameter 2r of the circle, that is the longest chord in the circle, is definitely greater than dB, that is not the diameter, and dB equals to 2 according to what is given as the question. So from this inequality we will derive that 2r is greater than 2. We divide this inequality by 2 and you get that r is greater than 1. So we should find out that the radius of this circle r is greater than 1 unit. If r is greater than 1, r cannot be equal to 1. So we cancel this solution. This solution is the correct solution. And we focus on the second solution for t. The second solution for t is that t equals to 6 minus 4 over 2, or 6 minus 4 over 10. It is 10 here. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution, for t equals to 1/5 from one side, but from the other side, according to our definition, t equals to 1 over r squared. So now we can substitute t by 1 over r squared in this equation. We'll do it now, and we get that 1 over r squared equals to 1/5. Here we cross multiply this equation, and finally we get that r squared equals to 5. Here we take a root out of this equation, and finally we get that the radius r that we are looking for is equals to either the square root of 5 units in itself, or in terms of numbers, it equals to 2.236 units. And again, we should find out that the radius r of this circle, it is equals to either the square root of 5 units in itself, or in terms of numbers, it is equals to 2.236 units. So in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have a circle. Inside the circle, we have chord dB is equals to 2. Chord AC equals to the square root of 2 units in its length. In addition, we have here angle DE. We have here angle BED. This is angle BED. This is equals to 45 degrees in its side. Again, this is angle BED. The size of angle BED is 45 degrees. Again, our mission is to find out the radius of this circle. So first of all, we join points D and A together by straight line. By joining points D and A, we can deduct peripheral angle BAD. This is peripheral angle BAD. The size of this peripheral angle BAD is x over 2. The next step, again, and peripheral angle BAD is subtended on chord BD. Again, this is peripheral angle BAD that is subtended on this chord called DB. The next step, we define the center of this circle. This point is point O. And then we join points O and B together by straight line. Likewise, we join points O and D together by straight line. By doing this construction, we get there the center angle DOB. The center angle DOB is also subtended on the same chord called DB, exactly like this peripheral angle DAB that is also subtended on the same chord called DB. Now we can implement here rule 13. So I repeat quickly on rule 13. According to rule 13, the central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle and we have, this is peripheral angle ACB. This peripheral angle ACB, the size of peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. Likewise, we have also the center angle AOB. The center angle AOB is subtended on the same chord called AB. And according to this rule, the size of the center angle AOB must be twice as large as the size of peripheral angle ACB, because both of them they subtend on the same chord called AB. Okay, and therefore the size of the center angle must be twice as large as the size of the peripheral angle that is subtended on the same chord called AB. We know that the size of this peripheral angle ACB is equal to theta, and therefore the size of the center angle AOB that is subtended on the same chord called AB must be equal to 2 theta. So we can actually implement rule 13 in our drawing. Why? Because in our drawing, this is peripheral angle DAB. Peripheral angle DAB is subtended on chord DB. And we have also center angle DOB. Center angle DOB is also subtended on the same chord called DB. Therefore, according to rule 13, the size of the center angle DOB must be twice as large as the size of this peripheral angle DAB that is subtended on the same chord called DB. The size of this peripheral angle DAB is x over 2. Therefore, the size of the center angle DOB that is subtended on the same chord called DB must be equal to x, according to rule 13. In the next step, we defined the size of peripheral angle CDA. This is peripheral angle CDA. We define the size of this peripheral angle CDA is 1 over 2. And this peripheral angle CDA is subtended on chord CA. In the next step, we join points O and C together by straight line, and we join points O and A together by straight line. By joining those two, by doing this construction, we get the center angle AOC. This is the center angle AOC. It is subtended on chord AC, exactly like peripheral angle ADC. This is also subtended on the same chord. Now, according to rule 13, the size of center angle AOC must be twice as large as the size of this peripheral angle ADC. Why? Because both of those two angles they both subtended on the same chord called AC. And you know that the size of peripheral angle ADC is 1 over 2, and therefore the size of the center angle AOC must be equal to y, according to rule 13, because both of them subtended on the same chord called AC. Okay? So, in the next step, I actually presented to you the law of cosines, and we implemented the law of cosines in triangle DOB. So, I'll repeat quickly on the law of cosines. The law of cosines is true in any triangle. So, this is triangle ABC that could be any triangle. This triangle ABC side, the length of side AB is A, side AC equals to variance incidence length, and side BC equals to series incidence length. This is angle BAC, the size of this angle BAC is theta. And according to the law of cosines, the following equation will be true. Cosine theta equals to a squared plus b squared minus c squared over 2 times a times b. Again, cosine theta equals to a squared plus b squared minus c squared over 2 times a times b. We can actually implement the law of cosines in this triangle DOB. So I copy triangle DOB in a new page and we implemented the law of cosines in this triangle DOB. We know that DO and BO, they are both the radii of this circle, and you find the radii and the radius of this circle is R, therefore DO equals to OB equals to R. Because point O is the center of the circle, point B is the point of the circle itself, therefore OB is the radius, OD is the radius, OA is the radius, and OC is also the radius. Both, all the 4 line segments, each of them is the radius of this circle. This is equals to R. R is the radius that we are looking for in this question. So in the next step I copied triangle DOB in a new page and we implemented the law of cosines in this triangle DOB. So actually this is triangle OBD or DOB that I copied from the original domain. DO equals to OB equals to R and sine DB equals to 2 units, and this is angle X. According to the law of cosines in this triangle DOB, cosine X equals to OD square. OD is R, therefore OD square is R square, plus OB square. OB is R, therefore OB square is R square, minus minus DB square. DB is 2, therefore DB square is 2 squared, that is 4. So in total, in the numerator we have R square plus R square minus 4, and according to the law of cosines, in the denominator we have over 2 times A times B. So it is over 2 times A is DO, and DO is R. So it is 2 times R times DB, this is also R. So it is 2 times R times R. So conclusion, in the denominator we have 2 times R times R. And in total, according to the law of cosines, cosine X equals to R square plus R square minus 4 over 2 times R times R. R square plus R square is 2R square. In total, in the numerator we have 2R square minus 4 over 2R square. 2R square over 2R square is 1. And we have also minus 4 over 2R square. Here we divided both the numerator and the denominator of this expression by 2, and finally found out that minus 4 over 2 is minus 4 over 2 is minus 2, and 2R square over 2 is R square. So in total, we found out that according to equation 1, cosine X equals to 1 minus 2 over R square. In the next step, I copied the right triangle AOC in the new page and implemented the law of cosines in this triangle AOC. So actually, this is triangle AOC. Then I copy it from the original domain. Side AO equals to side CO equals to R, and side AC equals to the square root of units in its length. According to the law of cosines, in this triangle AOC, cosine Y equals to OA square. OA is R, therefore OA square is R square, plus OC square. OC is also R, therefore OC square is R square. Minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2. So in total, in the numerator, we have R square plus R square minus 2, divided by 2 times A. So it is 2 times A. A is OA, that is R. So it is 2 times R times CO. CO is also R, therefore it is times R again. So in total, in the denominator we have 2 times R times R. So in total, according to the law of cosines, cosine Y equals to R square plus R square minus 2 over 2 times R times R. R square plus R square is 2R square. So in total, in the numerator of this expression, we have 2R square minus 2 over 2 times R, that is 2R square. So here we have 2R square over 2R square is 1, and we have also minus 2 over 2R square. So cosine Y equals to 1 minus, here we divided both the numerator and the denominator of this expression by 2, and minus 2 over 2 is minus 1, and 2r squared over 2 is r squared. So in total we actually found out that according to equation 2, cosine y equals to 1 minus 1 over r squared. In the next step, I copied triangle EDA in the new page and implemented rule 4 on this triangle EDA. So actually, this is triangle EDA that the comes from the original drawing. This triangle EDA, we have those triangles x over 2 and y over 2, and this third triangle, all those triangles are defined as the interangles of this triangle EDA because they are located inside triangle EDA. But this is angle PED that is located outside of triangle DEA, therefore it is defined as an external angle in relation to this triangle EDA. The size of the external angle BED is 45 degrees. So in the next step, I presented to you rule 4 and implemented rule 4 in this triangle EDA. So I click quickly on rule 4. According to rule 4, the external angle of a triangle is equal to the sum of the two internal angles that are not adjacent to it. So in that moment we have a triangle. Inside this triangle we have those triangles A, B, and C. They are all defined as an triangles of this triangle, and this is angle E. It is defined as an external angle of this triangle. According to this rule 4, the size of the external angle E is equal to the sum of the two triangles that are not adjacent to it. Angle C is definitely adjacent to angle E. And the two other angles that are not adjacent to angle E is those two angles A and B. And according to rule 4, the size of angle E is the sum of the two angles that are not adjacent to it. It is to say it is A plus B. Or the size of angle E is A plus B. So the sum of the external angle of a triangle is equal to the sum of the two angles that are not adjacent to it. The internal angle E is E. The sum of the two angles that are not adjacent to it is A plus B. So the size of angle E is A plus B. So we can implement rule 4 in our drawing. Why? Because in our drawing we have triangle DEA. Those three angles, this angle y over 2, x over 2, they are all defined as the internal angles, and this is angle BED that is defined as an external angle. So according to rule 4, the size of external angle BED must be equal to the sum of the two internal angles that are not adjacent to it. Those are the two internal angles that are not adjacent to it, and the sum of those two internal angles is of course is x over 2 plus y over 2. Therefore the size of this external angle BED must be equal to x over 2 plus y over 2 according to rule 4. Again, according to rule 4, the size of the external angle BED is equal to x over 2 plus y over 2. This is the sum of the two angles that are not adjacent to angle BED. Again, according to rule 4, the size of the external angle BED is x over 2 plus y over 2. But it is given as the equation that angle BED is 45 degrees, so substitute angle BED by 45 degrees. And we actually found out that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2, and finally found out that 45 degrees times 2 is 90 degrees, and x over 2 times 2 is x, y over 2 times 2 is y. So in total we actually found out that x plus y equals to 90 degrees. We subtracted x from this equation and finally found out that y equals to 90 degrees minus x. Okay. Well, according to equation 2, we actually found out that cosine y equals to 1 minus 1 over r square, and we just right now found out that y equals to 90 degrees minus x. Therefore, we can substitute y in this equation 2 by 90 degrees minus x. We did it, and we actually found out that cosine y, and y is 90 degrees minus x, equals to 1 minus 1 over r square. Here we have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So we can substitute cosine 90 degrees minus x by sinus x according to this trigonometric identity. We did it. We found out that according to this equation, equation 2, again we have cosine 90 degrees minus x, that is sinus x. So sinus x equals to 1 minus 1 over r squared. This is according to equation 2, while according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. We have the trigonometric identity that states that sinus square x plus cosine square x equals to 1. So now we can substitute sinus x in this trigonometric identity by 1 minus 1 over r squared, and we substitute cosine x by 1 minus 1 minus 2 over r squared, because 1 minus 2 over r squared equals to cosine x. So we did it, and we found out actually that sinus square x equals to, we know that sinus x equals to 1 minus 1 over r squared, and therefore sinus square x will be equal to 1 minus 1 r squared plus cosine square x. Cosine x is 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared, and this equals to 1. In the next step, we defined t as 1 over r squared. Again, t equals to 1 over r squared according to our definition, and now we can substitute 1 over r squared in this equation 3 by t. We did it and found out actually that we have here 1 minus 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared by t. So in total, the value of this expression will be equal to 1 minus t squared, and we also plus 1 minus 2 times r over r squared. So it is equal to 1, and we have minus 2 times 1 over r squared. 1 over r squared is t. So in total, the value of this expression will be equal to 1 minus 2t squared equals to 1. So we found out that after we substitute 1 over r squared by t, we found out that according to equation 3, 1 minus t squared plus 1 minus 2t squared equals to 1. So we open the brackets on this side of this equation, equation 3, and we found out that 1 minus t squared equals to 1 squared plus t squared minus 2 times t. We also plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, minus 2t squared, that is 4t squared, minus 2 times 1 times 2t, that is minus 4t, equals to 1. Okay, so here we have 1 on both sides of the equation, so 1 we get cancelled, and we cancelled 1. This side of the equation we have t squared plus 4t squared, that is 5t squared. We also minus 2t minus 4t, that is minus 6t, plus 1 equals to 0. So we have the equation 5t squared minus 6t plus 1 equals to 0. This is the quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. We find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Another specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t, so x equals to t. The coefficient a equals to 5, the coefficient b equals to 1 or 6, and finally the coefficient c equals to 1. The only thing that is left to do is to put the data inside this general formula for x, and this way we find out the value of the values of t, because x equals to t. So We did it, and we substitute x by t because x equals to t, and it's equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus b squared. B is 6, therefore b squared is 6 squared, that is 36, minus 4 times a is 5, therefore minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20. Okay, so inside the root we have 36 minus 30 divided by 2a. A is 5, so 2 times a is 2 times 5, that is 10. So conclusion, we shall find out that t equals to 6 plus minus. Inside the root we have 36 minus 20. 36 minus 20 is 16 divided by 10. Okay, so here we have two solutions that are possible for t. Again, we shall find out that t equals to 6 plus minus 4 over 10. Because the square root of 16 is 4. So 2 equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1 from one side, but from the other side, according to our definition, t equals to 1 over r squared. So we can substitute this equation by 1 over r squared. We did it. We found out that 1 over r squared equals to 1. Here we multiply this equation by r squared. And finally found out that r squared equals to 1. Here we took out of this equation and finally found out that r equals to the square root of 1. That is 1. So according to the first solution, and the radius r of this circle equals to 1. But it is impossible that the radius r of this circle equals to 1. Why? Because of the fact that we know that chord dB equals to 2, and chord dB is definitely not the diameter of the circle. Again, chord dB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. The diameter of this circle is 2r. And therefore, the diameter 2r is definitely greater than dB, that is not the diameter. Again, the diameter 2r is definitely greater than dB, that is not the diameter. And dB equals to 2. And from this inequality, we will derive that 2r is greater than 2. Here we divided this inequality by 2, and finally found out that the radius r of the circle must be greater than 1. The radius r of this circle must be greater than 1. If the radius must be greater than 1, the radius cannot be equal to 1. So we cancel this solution, and we have to only with the second solution that is possible for t. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t equals to 1/5 from one side, but from the other side, t equals to 1 over r squared according to our definition. So we can substitute t in this equation by 1 over r squared. We did it, and we actually found out that 1 over r squared equals to 1/5. Here we first multiply this equation and finally found out that r squared equals to 5. Here we took out of this equation and finally found out that the radius r of the circle equals to either square root of 5 units this time, or in terms of numbers, it is equals to 2.236 units. I repeat again, we actually found out that the radius r of this circle is equals to either the square root of 5 units, or in terms of numbers, the radius r of this circle is equals to 2.236 units. Okay, thank you very much.